Good morning, dear students. In the last video in wave optics, we have studied about coherent and non-coherent sources and how the waves are overlapping with each other. And while it's overlapping, what are the difference it is happening, construction and destructive. That is what we have already discussed in the previous video. And now we are going to discuss about interference. Interference, what is meant by interference? For example, interference comes from the word interfere. Interfere means, for example, in the class, if the teacher is asking some question, if someone is trying to answer for that question, in between somebody interfering that and he is giving some other answer. Okay, so that is what it is called, interfering. Okay, so it is interference that we can consider over here. Okay, so interfere means it is a kind of a disturbing in between. That is what interference is all about. Okay, for example, shall we take this as an example? In a plain water, you are throwing a stone in one particular place. The waves are created and it is going smoothly without any disturbance. And what you are doing on the other side, you are throwing the one more pebble on the other side. There also the wave is created and it is propagating. This wave, while propagating, will be disturbed by this wave. So because of that, there will be a superposition which is happening, which we have already discussed this in a different name. This phenomena of superposition of two waves to form a resultant wave of greater amplitude or lower amplitude. It may be a greater amplitude, it may be a lower amplitude. Okay, so this phenomena is called interference. Interference, that you can keep this as an example, that you hope you will understand this. Okay, and now you can see interference is the phenomenon of superposition of two waves that we have discussed. When the crest of a wave overlaps with the crest of another wave of same frequency at the same point, what will happen? Then the resultant amplitude will be the sum of the amplitudes. Amplitudes that we have already discussed. Maximum displacement from the mean position. So the sum of the amplitude of individual waves. Then this is known as constructive interference. Constructive means it is more productive. So the interference will be more productive. So it will be looking like constructive. So the amplitude will increase. That is what constructive interference is all about. The amplitude of the resultant wave will be more. Amplitude is more as compared to the amplitude of individual waves. If two waves are coming, and if you compare to that two amplitude, this resultant amplitude will be higher. Okay, so this is what an example we can consider for constructive interference. And when the crest of one wave meets through another wave, when the resultant amplitude gives as a difference of two individual amplitudes, then this is known as destructive interference. In this destructive interference, what will happen? The amplitude will reduces of the individual one. Individual amplitude will be more, but the resultant amplitude will be very less, or there is no wave will be created, which we have already discussed this, right? So the amplitude of the resultant wave will be less as compared to the amplitude of individual waves. That is two different waves which are coming, no? Compared to that waves, the resultant waves amplitude will be very less. So that what will happen? There is no productive. It is distracting each other. So it is called destructive interference. Okay, this is the example which I already told you. If two stones are dropped in a river, or ripples of waves which is generated by both stones, when both waves overlap, there will be maximum displacement when the waves are in phase, and there will be no displacement when they are out of phase. We have already discussed the wave should be have zero phase difference or constant phase, zero phase or constant phase difference it should have. Okay, that is what we have already discussed. So for coherent sources that we have discussed, no similar thing that we are discussing here as a interference. And next, based on this, we are going to discuss about Young's double slit experiment. double slit. There may be a single slit, double slit, two types of slits are there. And from hygiene, based on the hygiene's concept, Young's developed the Young's double slit and single slit experiments. We are going to see this elaborate how it is constructed. Okay. For example, we have already discussed about the coherent and incoherent sources. What is meant by coherent sources? Coherent sources means the waves which will be have same amplitude, that is phase difference should be zero, or it should maintain the same phase difference, right? So can we use everywhere laser? Is it possible? It is highly impossible. So what Young's is doing, he is creating a source which is having same phase difference by using a single light source. How is it possible? For example, this is the light. In between, there is a opening, a small slit opening which is kept over there. And in this, if the waves are propagating, means these are all the wavefronts which is created. Okay, this is like the wavefront which is created. How the wavefronts are created like this? I hope you remember this. Can you see this? In this diagram, the waves are coming as a plane wavefront. While passing in through the slit, it is changing its shape to cylindrical type, right? In this diagram, can you see this? Similar thing which is happening in here. One light source, a light is moving here, the wavefronts which is created like this, right? So this is single slit. In this path of waves, what Young's is doing, he is placing a one more slit which is having one more obstacle which is having two different openings, S1 and S2. This is slit 1, this is slit 2. So in this openings, what will happen? Similar kind of waves which is created in the previous obstacle. Here also the waves are created like red, yellow, like this. The waves are created like this. So what will happen? Here also similar waves which is created. These two waves where it overlaps. Overlaps means interference which is happening over here. So interference, if it is happening, if it is captured in one particular screen, so this is light source, this is the wavefront, and this is the slit, the two slit opening which is kept over here. When we keep a board-like structure, which is screen-like structure, if we keep it here, one dark and one bright like fringes, it is captured. So this is called Young's double slit experiments, YDSE. So this is a diagram, what is the theoretical diagram for this? So this is slit 1, this is slit 2. These two slits, S1, S2, acts as a coherent sources. What is meant by coherent sources? This will behave like a waves which is created with the same phase difference. Okay. So because of the same phase difference, what will happen? These interference which is happening over here. But the same experiment, if it is done with the not incoherent sources, but the sources which is created without coherence, means these dark and bright fringes are not captured. This is the specialty of this Young's double slit experiment with coherent sources. Okay. So at a particular point P, what is the interference which is happening over here? That is what the mathematical expression for this Young's double slit experiment. Now we will see the explanation for this. So Young's double slit experiment shows that the matter at the energy display both wave and particle characteristics. It proposed a double slit experiment as follows. That is, in order to prove that the wave nature in light, this phenomena of interference which is happening over here. Experimental setup 1. Young's took an ordinary source of light. Yes, source of light bulb. For example, bulb, he is taking one bulb. That is the diagram which is given over here. He is taking one bulb. Okay. And next what will happen? The light was made to pass through a very small slit S, which was comparable with the wavelength of light. Okay. And the light is coming from source S was made to pass through the two small slits S1 and S2. You can see here, this is one small slit and this is S1 and S2, two slits. A slit means a small opening. Okay, that is what you can understand. Don't get confused in that. Okay, a small opening in that obstacle. Okay, which were separated by a very small distance T. These two slits are separated by a very small distance. This is a very small distance that it can be managed. So one screen was kept in front of these sources. So what will happen? What is the observation? While observing, he observed that alternate dark and light bands were formed on the screen. Second one, as I said earlier, now he is taking two light bulbs as non-coherent sources. Okay, incoherent sources or non-coherent sources. He is taking of light is placed a screen in front of them. What is the observation which is happening? If two non-coherent sources, if it is taken, he observed that there was no alternate bright and light which is formed on the screen. So from this, what is the conclusion we come to? When coherent sources of light were taken, then the phenomena of interference is taking place. If non-coherent sources are taken, phenomena of interference is not taking place. Okay, so this is the explanation for this. This is slit, this is a crust which is happening. Red color showing its crust and yellow color is trough. So where the interference which is happening over here, the sources S is illuminated as S1 and S2, and rest of the light as S1 and S2 become coherent sources. This S1 and S2 will become coherent sources. S is the source of the light, was this both S1 and S2. Therefore, is any change in the phase of the source, there will be a change in both the sources also. So it will behave like a coherent sources. So therefore, both in S1 and S2 will be always with the phase of each other. So while the waves are intersecting each other, what will happen? Where the yellow and red meets over here, there is a destructive interference which is happening over here. Then red and yellow where it meets here, it is destructive interference. Yellow and yellow where it meets here, there will be constructive interference. White bright bands or bands are created, and red where interference, no, at that particular point constructive interference which is happening. So because of that, what is happening? Bright fringes which is happening. So red arrows were constructive interference, black arrows shows destructive interference. This is the red one where the red and red meets, yellow and yellow meets. Can you see this diagram clearly? And black color means red and yellow where it meets there is a destructive interference, there the black color fringes which is formed. Here the white color fringes formed. So dark and bright fringes which is formed over here. So kindly understand that these are all the phenomena which is happening only if the light in the form of a wave, not in the form of a particle. If it is in the form of particle, what will happen? There is no crust and trough. So if this is not there, there is no interference will happen. There is no interference means there is no dark and bright fringes will happen over here. So light, if it is considered as a waveform means these kind of phenomena can be explained. So this is a very important point which is taken from the light is having dual nature. It is considered as the waveform also. Okay. In the next video, we are going to see about the mathematical expression for Young's double slit experiment. Okay. Thank you.